Welcome to a series of videos on the use of IESve as a building performance assessment tool. And up to now, we've defined very much the inputs, energy use inputs and thermal gains and so forth, and ventilation of a typical building in IES. And the next step is now will be to define the, the construction parameters. And then once we've done that, I will share a video where we will then define it to the building itself, so that you're sure that all the parameters are applied. Now, in order to define the construction parameters, there are two ways to do it. You go through Apache Constructions, and then you'll go to the construction database. Or should you be in the thermal conditions database, then you can also click on construction database, which means similarly to the other inputs, again you are defining it as a template from which it then gets applied to the different materials. You see here currently is the assigned thermal conditions and non-thermal. Non-thermal is really not important because it's not going to have any implications in terms of any thermal conditions. And these are the defined materials at the moment. I would suggest that you don't fiddle with these, but that you rather prepare new materials. And as you can see down here at the bottom, you've got external wall, which talks about the external wall, a TSC wall, internal partitions, not really that critical. You've got the exposed ground floor, you've got the roof itself. You can define a thermally active roof. You can define the internal ceiling, which is good. Doors, as we noted, glazing, and then there's obviously some other aspects that you can also think through. But it's landscape is quite difficult to really include because ultimately the model only really considers the building envelope itself and the internal spaces. So you're really only focusing on that, the building in itself. I'm not going to unpack each time, each aspect about how you develop it. I will use a simple external wall, but what we see here is you have an understanding of what's currently being applied in the building, and you might want to say, okay, wait a minute, that's not correct. Then you can go and say, let's develop a new construction. Or you can say, oh no, I think a steel sheet wall is great, and I might choose to copy that and then paste it. I would suggest you simply start with a new wall. You start with a new wall, you double click on that, and you enter the wall condition. And you can call this masonry wall. And I often give it a depth as well. So you can even say, let's make this a plastered wall. So it's got a cavity in. You can even then say here plastered and 50mm cavity, for instance. Okay. Which means when you then look at what is currently defined, it's a brick wall, it's brick and blocks, the category, so we'll adjust that, and it's 220 mils. So it's kind of there, but it's not really there. Okay, so let's start by fixing it. We need to start by firstly defining the amount of layers that would be needed for this project, for this material. In order to do that, we need to actually increase the amount of layers that we see currently, because there's only really one layer. And we say, okay, wait a minute, we are going to have plaster on the outside, plaster on the inside. We'll have the two brick layers on the inside and outside, and we'll have a cavity in the end. Okay, so quite a bit. At the moment, it's a crazy thick wall, but it's not really accurate. And let's start with the plaster on the outside. We can choose on under system materials, you can then go and copy the material over that's appropriate. So let's go back. You go to systems materials and you go and select now the material. Now what's nice about IES is even though you can go and calculate the R value of all the materials, IES has a generally good basic basis from which you can define the material quality. So they've got density, conductance value, the thermal capacity, and so forth, all within the database. That from there you can actually do your analysis. So it's a bit easier to work with. So if we go to plaster, we'll say, okay, wait a minute, we'll use a dense plaster. It's not really a gypsum or perlite plaster, and certainly not plasterboard. And you simply go and say copy. You never change this. Close it, and then you'll paste this layer. There we go. Plaster dense. We've got that we've got the vapor, the resistance, the thermal capacity, the specific heat capacity, the density, the conductivity, and so forth. And we know the one thing we can adjust then is to say the depth of it. We know that the plaster is typically a 10 mils thick. Then we say we've got an outer brick layer. It's not 220 anymore, it's 110. And then we've got a cavity. So let's see, we've got to find an air space to provide a cavity in the end. Oh, I made a mistake. You can simply just define the cavity. So we will take this layer and we will delete this layer. And then we will insert a cavity. There we go. We've now inserted a cavity. And we say, well, okay, this cavity we noted would have to be 50 mils. And then we've got another brick layer. We can keep outer layer, it's not really that critical. It's 110 mils. And then we would like to take that plaster again. So we can copy this layer and we go to that and we simply paste it in. And there you go. And there we go. We've got a 290 millimeters thick wall. It generally has a U value of about 1.53. It's about 0.4, so it's still not really great for thermal resistance, but we know that it's because it's not insulated. And there you go. You can then press OK, and you've got your first material sorted. Now, I'm not going to do it for every surface, but this is essentially how you will adjust the construction of your project. And I suggest you do it beforehand when you've collected the information. Then you prep all the materials and you can then assign it to the different components in the model. In the next video, we will go to Apache and we will then assign the construction of these different aspects to the model. So you can ultimately see how that relates to the geometry we've created. And then once we've got the geometry, then we can commence with our analysis. Yeah, it takes a bit of time to prep, but it's once it's done, it's actually you can get quite a lot of data quite quickly. Good. See you in the next video.